Okay, so today we're going to talk about something that's called boxes and devices. We already have played with some of that during the lab. So the devices, what kind of a device we have touched so far? We have touched the duplex receptacle, actually twice right now, or for some of us because lab 2 is still going on. And what kind of box we have dealt with so far. Well, as we go along, maybe you can identify it yourself. All right, so this is a two-tiered class. Let's see if we are going to be able to carry on through the whole thing. Boxes and devices, right? Um, right off the start, we have something that is, well, really uncommon, but once in a while you're going to see something like that. What is wrong with this picture here? That, well, it does have some boxes and it does have some devices. If you can consider a wire not a device, I suppose you could. What is wrong with this picture? Well, the basic question would be what is right about this picture, and as we go along you will be able to identify the problems with this. All right, so I'm going to read some of it and I'm going to stop and go and explain as I always do. So Canadian electrical code determines the amount of wires in an electrical box that the electrical box can hold based upon the following things. So if you have an electrical box, um, can you fit just as much as you possibly can as long as the lid closes? No. Can you do what is on the picture? No, you can't. If this was a new installation and an inspector walked in onto site like this, I think the inspector would probably do something like, I don't know, maybe he would lay an egg. All right. Um, Obviously, this is not a photoshopped picture, so this thing actually was somewhere, and when somebody saw that, they actually took the time to take a picture to show what's wrong. In my journey as installer for some years, have I come across different situations? Yes, there were situations that I actually stopped and took pictures of things that have been installed wrong. So after you go through this class and classes after that, you will not do this kind of stuff, right? Right. All right. So, so you can only fit so many wires and other things in the box, such as devices, based on the following things: the total volume of the box, and the volume of the box is determined by the units of milliliters. A liter is a unit of a volume, and if you buy the big bottle of pop, it's well, check it out. How many milliliters or how many liters is that? So that should give you the idea of what a liter is. Um, and what is a milliliter? Milliliter is 1,000th of a liter. So you can only fit so much stuff or so many things in the box based on the volume of the box, which is specified in milliliters. And when it comes to wires, based on the American wiring gauge, which would be the AWG thing right here. So how big is the box and how thick are the wires? The type and size of the device mounted on the box. So, well, the device would be a switch or GFCI. GFCI is a ground fault circuit interrupt, and switch would take less space in the box. GFCI would take more space in the box, and we will go through some of that. So based on the size of the device, Well, sometimes you can fit more wires in there, and sometimes you can fit less wires in there because based on what else is in the box. Right? So far, it makes sense. Not a big philosophy here. And the number of wire connectors in. Well, I think this in should be eliminated here. So based on the number of and these will be the wire connectors right here, for example. So you can only fit so much stuff in the box based on how much and how big the thing is, those things are. That's basically what this picture says here. Number of conductors in the boxes. So there would be box dimensions in size here, and there will be type of the box, right? Box dimensions, trade size. So 4x1, and we'll talk about how we do the size here. So 4 inches by 1 inch. Okay, we can say that 4 inches. So octagonal box, 4 inches by 1 inch. So the size of the one of the side, length of the side, and length of the other side. And here's here's the size of the side because it's a octagonal box, and then there's the depth of that. Okay, so 1.5 inch or 2 1/8 inches. Right. So here's the size of one of the sides because octagonal square boxes. That's probably the easiest way to say square. You only have to specify one side because it's a square box. Okay? So it would be 4 inches of one side of the square. And how deep is that? So 4 by 1.5. What would be the capacity in milliliters? So it would be 344 milliliters of that. Or if you really want to do it in the imperial units, you can just say that because in brackets here, that's how you understand this table. This would be 21 square inches. Oh, sorry, cubed inches. All right, so maximum number of conductors. This is how you read this kind of tables here. You can fit in the box 14, total number of 14 of the 14 gauge wires. You can fit total number of 12 gauge. You can fit total number of 9 of the 10 gauge. Right? So that's how you read that. Now, round box, here's the diameter, and here is the depth of that. Now, there's some other boxes, well, sort of like rectangular boxes. So it would be 3 inches by 2 inches. So see, we're mixing the units here. It's living in North America is you have to deal with two measuring type of systems. The imperial and metric. So Canadian electrical code right here in this previous picture slide, we're specifying the volume in milliliters, but we're specifying the size of the box in inches. So figure that. Okay. All right. So let's say device 3x2, 3 inches by 2 inches. You can tell that this is a single gang box as we go further along, because that 2 inches here tells you that this is a single gang box. Don't worry about that. If you don't understand what I'm saying right now, as we go along, you will. So 3 inches by 2 inches, and here's the depth, 1.5 inches. Oh, wow. And here is the, well, volume of the box, and over here is in milliliters, and over here is in cubed inches. And what can we fit here? It's a smaller box, right? 3x2. So you can fit 5 of the 14 gauge wires. All right. Now, as we go thicker with the wire, so we are lowering the number of the gauge, which means the wire gets thicker. Okay, here's the thinnest wire. Here is a little bit thicker. Here's a little bit thicker. Here's a little bit thicker, and here is more than a little bit thicker. All right. So let's see, 3x2 by inch and a half. You can fit 5 of those 14 gauge wires, and other wires you can just go along with the table, right? So if you have 10 gauge wires, you can fit only 3 of those. We're also going to have to see or define on what is considered to be a wire or a conductor, because everything has to be defined. But you see here, 3 inches by 2 inches. So 3x2 by inch and a half. So this is the depth of the box. Here's the same size of the box, but it's 2 inches deep for installing slightly bigger devices. Sometimes you have a, well, GFCI, for example, and we'll talk about what GFCI is. It's a bigger device. So suggestion is that you install deeper box so you can fit thing in it and with some wires in it as well. So you see that deeper box, of course, is going to have more volume. So here's 131 and here's 163 milliliters. All right, so 14 gauge wires, you can fit one more in there. Fit one more, you can fit one more, you can fit one more. Right? And you can just go along that table, and I'm not going to read out all this stuff, but you know how to read this table right now. All right. Here's a table 22, space for conductors in boxes. And here is the electrical code information, which you're studying in another class, but I'm just giving you some heads up over here. So usable space required. So you can, this is looking at the same thing, but from a different angle, if you will. Right? So size of the conductors in the gauge and usable space required for each insulated conductor in milliliters. So one conductor of gauge 14 in a box requires 24 usable space, 24 milliliters, 24.6 milliliters. Gauge 12 requires more space. Gauge 10 requires more space, and so on. Okay. Keep going. All right. Not going to read the whole thing. I'm just going to point some things to you, because sometimes when you read the code, it's almost like reading the lawyer's digest. Okay. So maximum number of conductors in the box. I'm just going to bring your attention to certain things here. Boxes shall be of sufficient size to provide usable space for all insulated conductors contained in the box. And here's subject to following. You can substitute subject to following with just one word, but. There's always a but. A conductor running through a box. See here. What is a conductor? This is, we're talking about what do we consider as a conductor. Okay, so A, B, C, D, and D, let's say, for example, number A or letter A. A conductor running through a box with no connection therein shall be. Okay, so there we go. There you go, the lawyer's language here. Let me read this thing here and let me explain it to you. A conductor running through a box with no connection. So here's the first part of the sentence. So there's a conductor running through the box, and it's not connected to anything. And it says, therein shall be considered as one conductor. Okay, so if we have a conductor running through a box with no connection, should be counted as one conductor. Each conductor entering or leaving a box connected to a terminal or connector within that box shall be also considered as one. Right? So we have two scenarios here. A conductor running through a box and it's not connected to anything is considered as one conductor. Each conductor entering or leaving the box, which is connected to a terminal or a connector within that box, we're also counting it as one. So if you have a wire or conductor running through the box and it's just entering through one knockout and leaving through another knockout, it's considered as one conductor. But if you take your cutters, you cut that conductor in half, you interrupt the, you just cut it, and you connect one part of that to something, and you connect that other part to something else, then you basically have two conductors out of that one. A conductor of which no part leaves the box. So we have a wire that is in the box, and let's say it is connected to something in the box, and the other end of that is connected to something else only in that box, but no part of that wire leaves the box. We are not counting that. We are ignoring it. We are just saying that doesn't exist. It's not counted as one. It's just counted as zero. Right? What this one says: number 18, number 18 and number 16 gauge fixture wires supplying a luminaire mounted on the box containing the fixture shall not be counted. What is a luminaire? A luminaire is a well, it's a lighting housing for lighting. Sometimes what you're going to have is you're going to have a light assembly, and some of the light assembly will have thinner wires coming out of the light assembly. So if that's the case, then we are not counting them as conductors. All right. All the other stuff here, you're going to learn while you continue to study the code with other professors. I just want you to, I just wanted to get you started on thinking certain way when you are reading the code. And I'm pretty sure most of us already have that way of thinking already started. It happens by itself. All right. So let's summarize just this part here of what do we consider as a conductor, because it will be on a test. So again, the boxes shall be sufficient size, so the box should provide enough volume for the wires to be inside those boxes of wires and devices, right? But now we're talking just about the conductors. A conductor running through the box. So if the conductor just enters the box and leaves the box and it's not connected to anything, it's considered as one, right? So that's the A here, right? Then each conductor entering and leaving a box connected to a terminal. So if the same conductor, if you interrupt that and you connect one wire to something in the box and you connect it, all of a sudden you have two wires. From that one wire, you just made two conductors. So you're counting them as two. And a conductor, if there is a wire inside the box that basically is there, but no part of the wire leaves the box, then we're not counting that wire. And the wire supply from within the luminaire, and these are the 18 and 16 gauge wires that basically they're connecting to the light bulb fixture, part of the assembly, we are not counting them as well. Okay. All right, let's take a look at some of the some of the boxes here. Single gang box. You see this length here? This is just a regular single gang box. This is 2 inches here. 2 inches by 3. So 2 by 3. And this part here, this number here, right here, this number is the depth of the box. So it's 3 by 2 by 2.5. So 3 by 2 by 2.5 deep. Okay. What I'm saying is that if you see this 2 inches here, that's a single gang box. It would fit one type of device such as switch or a duplex receptacle. This 2 inches is a standard size for something that's called a single gang box. Single gang box. And this box can fit 8 of 14 gauge conductors. All right. Nice one. Single gang device box, most common sizes and uses. So single gang box, that's the single gang box. Looks familiar? That's the utility box that we also have. It's also a single gang box. Most common sizes and uses. So the box comes with 3 by 2 by 2.5 or 3 by 2 by 3 inches deep. So this 3 by 2, 2.5 inches deep. So if you see 3 by 2, you can just say single gang, right? So here it goes. Single gang box, 2.5 inches deep. Or you can say single gang 2.5. It's usually for duplex receptacle and for switches, such as light switches. Now, here's a deeper box. So here's a single gang, 3 inches deep, and that's recommended for GFCI because GFCI, it's a ground fault circuit interrupt. This is the one, it's the duplex receptacle that you can see close to kitchen sinks or close to bathroom sinks or in a bathroom. I don't know where there's water. Then
Nice.
yeah, I think somebody has some problems there. All right, so GFCI is the one that you have a button to press to reset that, because if any of the electricity is, can you please turn your microphone off, whoever that is? Don't have time for this, please. Okay, I'm polite. So deeper, so that it's a bigger device and it requires deeper box. Front face of the box extends 2.5, half inch in front of the stud wall. What does this mean? This means that, you see here, there's a little bit of guide knockouts here, or grooves, or spikes. This spike here is half inch deep into the box. So when you're installing this box on the, let's say, wood or timber framing, this box is going to stick out half inch towards the front of the wall, because when you install the drywall, when the drywall is installed, the drywall is half inch thick. So on the bare framing, if the box sticks out half inch, then you put the drywall on it, the surface of the box, the face of the box is going to equalize with the drywall. So it's going to be flush with the wall. Right? So that's what this means. All right, single gang boxes with devices terminated. Well, here is a box with a three-way switch, and we'll go through that, what the three-way switch is. And here's one with the four-way switch. Okay. Just an example. See that here, if there was an angle, this is a bare frame, and this face of the box sticks out ½ inch, because when you put the drywall on that, then the drywall will be flush with the face of the box. Single gang device boxes, cover plates. Well, here's an example of a duplex receptacle faceplate, and here's an example of a switch faceplate. Okay. All right, two gang device box, or a double gang. You see here, 3 inches, so that 3 inches stays because we're just going sideways with that. And instead of 2 inches, we have 4 inches. And this one is 2.5 inches deep, right? So this would make a double gang box. It can fit 16 of 14 gauge conductors. 4-inch square box. So he will be 4 inches, 4 by 1.5. So if it's a square box, you only have to specify one side of it, because in a square, all sides are equal. So we don't need to say 4 by 4 by 2 and by 1.5. Just say 4 by 1.5. Right. So that can fit 14 of the 14A gauge wires, not often used in residential wiring, although you can. Exception cable connections with no devices. So usually those are being used as so-called junction boxes. 4-inch square box as a connection for a circuit. Now, there's no device installed. They're just wires coming in. So this is basically being used as a junction box. All right. 3 gang box. We are going to go up to 25. No, just kidding. 3 gang device box. All right. So look at that. Single gang is 2 inches wide. So 2 times 3 is 6. All right. Okay, got it. Got it. So 3 by 6. Excuse me, by 2.5. And it can hold 24 of 14 gauge conductors. Can you see some of that? Walk in some of the classrooms and see if we have multiple gang device boxes installed just by looking at the faceplates. Usually you have a bunch of light switches quite often. All right, so here's a 4 gang box. Okay, you get the idea. Now, plastic 4 gang boxes. So the boxes are not always used for electrical, especially if you're dealing with AV situations, audiovisual situations. And especially if you're dealing with like, well, home theater in the basement or in your living room. But also those are being used in such things that are called conference rooms or conference settings. Here's an example of one. Here's an example of another. If you are thinking about if you are thinking about starting up your own business in doing this kind of stuff, talk to me. I will point you to I'll give you some phone numbers and websites for the distributors that are selling those things. Yes, you can go to the local hardware store and you can buy 1 or 2 of these. But if you are doing this thing on a regular basis as a business, and instead of buying 1 or 2, you all of a sudden you have to buy 30 of those, then maybe you should take a look at some of the distributors that do not sell to public, but to established businesses. And then there's ball boxes, Ganga ball boxes. So there's a box that is single gang, and if you have two of them, you can make a double gang box. So sometimes you can have those boxes that you can disassemble. They're not just one piece. You can take off one side from this one here, and you can take one side from this one. You can screw them together just like Lego pieces. There's that one. There's a reason why you were introduced to all those Lego blocks and all that as a kid. You think it was for play? No, they were trying to get you to be the future worker. Well, you know what? That's good because if you are a worker, that means you can support yourself and your family. Right. So, yeah. Right. So you can have those that are called gangable boxes that you can just assemble them just as Lego pieces. And there is an example of that assembled. Two single gang boxes assembled into double gang box. So sometimes you might want to have a stash in your working van if you're installing that. So if you're in a pinch and if you don't have multiple gang box, then you can assemble one. But when it comes to doing projects, and if you're planning to install, just instead of wasting time on assembling those, you can just order the right amount of the right gang number of the boxes. But it's a very versatile thing, this one here, that well, if you don't have one, you can make one and still finish the job before the sun comes down, or sometimes after the sun comes down. All right. All right. Gangable boxes used mostly for adding devices to existing installation. All right. I want you to research that on your own. And there's a lot of information on the net. This is 2022, year 222. You have all kinds of information right at your fingertips. In research, something that's called an F clip or F bracket or F strap, because it looks like a letter F. These are used to mount devices to already existing installation that you don't have to rip the drywall. And if you don't know where the studs are, or if you know where the studs are, but you need to go between this framing, the studs, and you just want to mount the device right on the drywall itself, then you can use those F clips. It takes 2 seconds. They take, well, not maybe a little more than 2 seconds to install, but they're quick, and they're very, very useful when it comes to you being able to do a job, period. All right, common devices used with the gang boxes. Well, here's a single pole switch, or sometimes you can call it a one-way switch, but for the most part, we're going to call it a single pole switch. Or here's a duplex receptacle, the stuff that we have played with it already twice. Duplex receptacle tab or tab. Remember when when we were showing you on the during the labs? Here are two screw terminals on one side and two screw terminals on the other side. Here is the longer prong, here's the shorter prong, and here's the bonding prong. This shorter prong is connected to these two screws, and so is this one connected to these two screws, and the same thing on the other side. And this bonding prong is connected to somewhere at the back. You can see it. It's the bonding terminal, screw terminal. And of course, just as a recall, which of these two is which is which is whistling, and which is not? Well, the shorter prong and the longer prong, one is hot and one is neutral, and thus, as just as a reminder, the hot is a shorter word. It takes less letters to write, to spell hot, than this takes to spell neutral. So neutral is the longer prong because it's a longer word. It's one way to remember. And hot is the shorter prong because it's a shorter word. H-O-T. That's it. Right? Now, you have two. It's because it's called duplex receptacle. That means you have two receptacles. And because there is a, okay, so this prong here is connected to this screw terminal. And this prong is connected to this screw terminal. And these two screw terminals are connected to each other with this tab, which you can remove. Just take your needle nose pliers and just break it off. And notice on this picture, you have somebody's doing what somebody's doing here. They are removing or splitting the hot terminal instead of the neutral. You can leave the neutral as it is, just like here in this picture. And instead of 14.2, you can use 14.3, for example, or 12.3, because you might want to up the gauge, because then you will, that neutral wire is going to work twice as much. And you can split that. So this top receptacle can be connected to its own circuit breaker in the electrical panel. And this bottom one can be connected to its own separate circuit breaker in the electrical panel. So you can have two circuits, but you have to break this tab. So you're separating them. And neutral you can leave as it is because everything comes back on neutral. And you would use 14.3 cable or 12.3 or 10.3. You connect the neutral as it is to the neutral terminal. And you have the black wire, which is hot, which would connect to one circuit breaker. And because they're separated, then you have another hot, which is connected to another circuit breaker, a separate circuit breaker. So you have two circuits. Where would you want to use them? You could use them, what's a very common use in the kitchen countertops, for example, when you need more amperes, especially imagine in the morning. Everybody wakes up, the whole family wakes up, and there's a toaster going, there's a coffee maker going, there's all kinds of other devices going, there's blah, blah, there's a blender, da, da, da. You can overload the circuits pretty quickly. So that's why it's a common thing to install duplex receptacles in situation like, for example, a kitchen countertop. Where else? Excuse me. Workbenches. And some power tools and stuff like that. Well, wherever you need more amperes. Let's talk about ampacity. What's ampacity? Ampacity is the ability to carry current and is the measure of carrying current. So the regular, oh, here's example of GFCI. See, that's the one that it's called ground circuit fault interrupt, or sometimes they're called GFI, ground circuit interrupt. I will explain that thing a little bit more to you for you probably next time we see each other. So the ampacity of that, it's rated for 15 amps. So the ampacity of that is 15 amps. And it has this type of a footprint. Here's a shorter prong, here's a longer prong, and here is a bonding prong. See what's different about these two? Here's a footprint for one. Here's a footprint for the other one. See that little extra kind of a shape thing that makes it into a T shape? Well, that means that this thing can be rated for 20 amps. Right? So what happens is, like, for example, window air conditioning unit. Quite often they require 20 amps, and they would have a plug with this footprint. It will draw 20 amps. In electricity, the devices or the load, it does not ask for the current. Whatever the device is, and if it is meant to work on 20 amps, it will not ask the electrical panel, Mr. Electrical Panel, can I have 20 amps, please? No, it will draw until it gets 20. And if the electrical panel is able to supply less, then it will still try to draw. If the cables are designed or rated for less than 20 amps, it will still pull 20 amps through the thinner cables, which might cause them to overheat, but the load doesn't care. Actually, no, there's not even a question about cares or not, because load just is. It's not aware of itself. The load just takes the amps of whatever it's rated for. So if there's an air conditioning unit, it will have, that's rated for 20 amps, it will have this footprint on the plug. And it's made in a way that you cannot plug it in. If you wanted to plug it in into a circuit that's rated for 15 amps, you won't be able to plug it in. But if you have a circuit that is rated for 20 amps with this footprint, then yes, you will be able to plug it in. So that's why we have those different footprints. And you have, excuse me, this footprints right here for different from different devices and for different ampacity. Just download later on when it's going to be available later on today. Download this lecture notes and just look at that and study that and find it in the electrical code as well. See what that says. This is the last slide for this, and that's where we're going to stop. But I'm going to leave you with one question. Sort of a thinking challenge question. Let's say you have an electrical panel with a circuit breaker installed in that electrical panel that is rated for 15 amps. And on the other side of the cable, you have this duplex receptacle right here installed, which is rated for 15 amps. And if you get the window mounted air conditioner, for example, portable air conditioning unit, that is rated for 20 amps. So what do you have to do in order to supply the proper equipment for the window air conditioner? What do you have to change in order to accommodate that window air conditioner? Well, we can change the receptacle for the proper footprint that can accommodate 20 amps. Is that enough? Anybody can respond to what I'm saying here? Is it enough to change the receptacle? No. Brian says no. That's correct. What do you need to, what else do you need to replace? Anyone? What's that? There was that movie. Anybody? Anybody? All right. If the unit, yes, thank you. Thank you, Ethan. We also need to replace a circuit breaker. So we replace the receptacle so we can actually plug it in, so we can accommodate the footprint of the plug. But if the unit is going to try to draw more than 15 amps, it is going to trip the circuit breaker. And well, the whole thing is going to shut down on us. So we also need to replace the circuit breaker for one that is going to handle 20 amps. And you have the whole thing done. Nice and happy, right? I need some confirmation from someone. We replace the footprint and we replace the circuit breaker and we are done. Is that correct? I have 2 people responding so far. I need somebody to respond to what I'm asking now. Brian says yes. Thank you, Brian, for being brave and say yes. So kudos. But it's actually wrong. All right. Think about it. We have the footprint. That's fine. We have the circuit breaker. That's fine. What is the one more element that we absolutely have to address if we replace the cable ampacity? There we go. Because gauge 14 is rated for 15 amps. And what is going to happen if you run more amps to a cable? First of all, it's not going to pass the inspection. Second, you are causing, you can cause heat. And heat, what heat causes? Heat causes fire. And this is something that you don't want. So always remember about the cable ampacity as well. And hint, hint, this might be on the test. Cool. It's 10 to 9 right now. I'm going to leave you with this and we're going to continue next time we see each other. Cool. All right. I'll see some of you in the labs and I'll see some of you also on the next online session. Thank you very much. Have a great day.